During the Orionid meteor shower in October 2022, a fireball was photographed in North America. Long streaks of luminous debris were left in the sky by other meteors. An asteroid that had struck Earth's atmosphere in March 2022 was intercepted by a meteorological satellite a short while before. Luckily, there was no disaster caused by the asteroid, which was known as 2022 EB5, since it was just 2 meters (6.5 feet) broad. However, not every cosmic collision is as secure. A few of them possess the power to harm or perhaps destroy planets. What explosion has been photographed that is hundreds of times the power of all of our nuclear weapons combined? Which cosmic explosion created an area surrounding it that could hold several galaxies? And what particular meteorite set off the Earth Defense Program's inception? Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. Astronomers frequently witness cosmic disasters. Additionally, in 1993, preparations were made to see the 1994 collision of the comet Shoemaker-Levy 9, SL9, with Jupiter. However, it was discovered at the last minute that the collision would take place on Jupiter's night side, making the initial impact invisible from Earth. The only spacecraft to witness the sight up close was NASA's Galileo, which was traveling to the gas planet. About 60 kilometers per second, or 37 miles per second, is how quickly the comet entered Jupiter's atmosphere as recorded by the space probe. Galileo photographed the arrival of a fireball at 1-second intervals and noted that its highest temperature was 23,700 degrees Celsius, 42,700 degrees Fahrenheit. Soon, this fireball became visible from Earth thanks to Jupiter, which rotates around its axis in just 10 hours. Then NASA's infrared telescope photographed a fragment of SL9 that was still rising over the edge of the planet after the initial collision on the night side of Jupiter. However, the Hubble telescope's high-resolution camera produced the best pictures. For a week, the telescope beamed at least once a day. As the planet turned slowly, black patches on Jupiter caused by the collision of the comet pieces could be seen. The collision between 21 SL9 fragments in the gas giant has been captured on camera by the Hubble Space Telescope. About 3 times the distance between Earth and the Moon, or approximately 1,140 kilometers, 710,000 miles, could be seen in the photograph as comet fragments. Other telescopes and observatories also maintained a close eye on things. Fragment G, a massive comet fragment, was the source of the greatest impact. As a result, there is now a massive dark patch that is more than 12,000 kilometers, 7,500 miles, broad on Earth's surface. This is practically how big the Earth is. 6 million megatons of TNT worth of energy were unleashed by the explosion, according to some estimations. This was 600 times more explosive force than all of the world's nuclear weapons at the time. The effects persisted throughout the interim. 2 further explosions occurred at 12-hour intervals, leaving nearly identical tracks to those left by the G fragment. Massive debris plumes from the collision shot into space, towering 3,000 kilometers, 1,900 miles, over the tops of the clouds. They descended down to the planet's surface a few minutes later, transforming it once more into a raging inferno. Massive energy waves from the collisions also surged across Jupiter at a speed of 450 meters per second, or 1,476 feet per second. For several months, the impact's patches could be seen on the gas giant's surface. Some of them were much more pronounced than the well-known Great Red Spot. But no matter how enormous the disaster was, it gave astronomers a lot of insightful knowledge. Scientists had a brief opportunity to peer inside Jupiter's atmosphere as comet debris collided with the gas giant. Astronomers gained new insight into the chemical makeup of the planet as material from its lowest layers was thrown into the thick clouds above. 2 atoms, sulfur and sulfur-carbon, were discovered by researchers, along with the release of heavy iron, magnesium, and silicon atoms. Though less than anticipated, instruments have also found a layer of water in the atmosphere. The deeper layers of the atmosphere, where the SL9 particles failed to penetrate, may have a layer that is more water-bearing, according to researchers. Furthermore, wind movements were tracked by the shock waves that swept across the Earth following the impact. And shifts in the polar lights on the gas giant demonstrated how the magnetosphere is influenced by comet and asteroid particles. The incident also increased scientists' awareness of the need to shield Earth from these cosmic bodies. The majority of them, including SL9, are trapped by Jupiter's strong gravity. It is estimated that the frequency of comets and asteroids striking Jupiter is 2,000 to 8,000 times greater than that of earthly collisions. Scientists think that complex life may not have arisen on Earth in the absence of this cosmic vacuum cleaner. However, the gas giant is unable to always protect us. There are craters on the Moon, Mars, Venus, and of course Earth from impacts with celestial rocks. Our planet already has a large crater from a previous asteroid impact, which led to natural calamities and the extinction of the dinosaurs. Dangerous cosmic visitors still frequently visit Earth today. On Halloween 2022, a massive asteroid passed near Earth. This potentially dangerous device would be nearly identical in size if it were placed next to the Burj Khalifa in Dubai, one of the highest skyscrapers in the world. The asteroid known as 2022 RM4 is estimated to be 740 meters, 2,428 feet in diameter, while the Burj Khalifa stands 828 meters, 2,716 feet tall. This granite mountain was traveling at a speed of roughly 52,500 miles per hour, or 84,500 kilometers per hour, and that's around 68 times the sound speed. On October 31st, the asteroid was photographed in Italy as part of the Virtual Telescope project. It passed by Earth by 2.3 million kilometers, 1.43 million miles, the following day. Even though that is around 6 times further away than Earth's typical distance to the Moon, it is still extremely close by cosmic standards. Thus, although there is still a lot going on in our solar system, it is a far more tranquil environment than it was 4.5 million years ago. Just as SL9 damaged Jupiter, any random astronomical object may potentially damage Earth one day. In order to avert this potential calamity, a solid defense system against comets and asteroids was to be constructed, and identifying potentially dangerous space objects was the first step. Only a few groups of astronomers were looking for asteroids in the inner solar system up until the mid-1990s. However, following the Shoemaker-Levy comet impact on Jupiter, we coined the phrase planetary defense, and additional research teams joined the fold. These days, scientists collaborate to monitor near-Earth objects, particularly asteroids that approach Earth's orbit within 48 million kilometers, 30 million miles. 90% of asteroids that are 1 kilometer or larger and possibly dangerous have already been found by NASA. Currently, the organization is trying to detect 90% or more of asteroids that are between 140 and 1,000 meters, 450 and 3,300 feet in width. Worldwide space agencies are searching for strategies to divert the orbits of celestial bodies that pose a threat to Earth concurrently. In September 2022, the DART spacecraft diverted the asteroid Dimorphos by modifying its orbit in the very first test of Earth's defense system. China has also planned a mission to change the flight of the asteroid 2020 PN1 in 2026. Global threats to Earth from space have also been considered by scientists. Several times, scientists have photographed incredibly strong explosions in different star systems and galaxies. The Ophiuchus galaxy cluster outburst is thought to be the strongest ever seen by human eyes. Multiple telescopes captured images of the massive flash. The blast was so strong that it blasted a hole in the plasma cluster around a black hole the size of 15 Milky Way galaxies arranged in a row. The entire event took place approximately 390 million light-years away from Earth. Scientists had the chance to examine this enormous event using data from NASA's Chandra X-ray Observatory, ESA's XMM Newton, the Murchison Wide Field Array, and the Giant Meter Wave Radio Telescope. This explosion of incredible strength produced breathtaking photos for us to view. However, NASA detected an explosion in the universe that reached Earth in October 2022. Scientists think that 1.9 billion years ago, in the constellation Sagitta, a black hole formed in the center of a supernova, which is what created it. Following the explosion, a wave of X-rays and gamma rays entered the solar system and swept across it, releasing the gamma ray burst, GRB 221009A. This event set off the detectors on the space telescopes Fermi and Swift. Fermi obtained data on the energy of gamma rays and discovered photons with energies greater than 100 million electron volts. In contrast, visible light photons have energy of roughly 2 electron volts. About an hour after it was first discovered, The gamma-ray burst's afterglow was photographed by the Swift X-ray telescope. Its brilliant rings are caused by X-rays that scatter throughout the dust layers in our galaxy. But the gamma-ray explosion didn't do any harm to our globe this time either. Due to its great distance from the epicenter, very little radiation made it to Earth. Perhaps there would have been problems for the Earth if it had happened near us. One of the strongest forces in nature is a supernova explosion. It has the capacity to produce as much energy as the Sun does over its lifetime. Such a gamma-ray deluge possesses amazing destructive capability. It would cause the atmosphere to evaporate and turn all life on Earth into ash. And scientists think that something similar has happened to our planet at least once in the past. According to NASA, some 445 million years ago, a deluge of gamma rays hit Earth after a supernova explosion. One of the largest extinctions on Earth, the Ordovician Silurian, may have been brought on by it. It is believed that the catastrophe's perpetrator was located in the Milky Way's near-Earth arm. Its radiation caused the ozone layer to be destroyed in half and caused the extinction of nearly 85% of all living things. We are only at risk from a supernova explosion if it occurs no more than 50 light-years from Earth. Thankfully, among our nearby stars, no supernova candidates have been discovered to date. However, there's still a risk that a wandering star, primed for explosion, could appear out of some cosmic corner. Alternatively, a deadly star may be hiding from observers in a remote area of the Milky Way. Therefore, it would be wise to include supernova detection in our program for planetary defense as well. Which scenario, a wandering star on the verge of going supernova or a very minor asteroid hiding someplace in our solar system, do you believe is most likely and harmful for us? Please hit the like button and subscribe to the channel in order to receive updates on any amazing space-related events. I appreciate you seeing.